Hello guys, this is CodeNCode and this is video editorial for the problem accurately taken from div2 round 652, and this was a big problem. So the problem is we are given a string of length n, which is a binary string. Binary string means all of the characters of string s are either 0 or 1. So we can perform as many operations as we want, and the operation is of this type. So if the ith character is 1 and the next character is 0, that means there exists a substring of type 10. Then you can remove exactly one character, either 1 or 0. So if in the original string there exists a substring 10, you can remove either 1 or 0. So this is the operation that we can perform, and we have to find the shortest, cleanest uh, sub string that we can form after performing as many operations as we want. So of course, after performing an operation, the length of the string reduces by 1. So we have to find the shortest string, but also if there are for example, if the initial string length was 10 and you are able to generate a string length 3 after performing several operations. Now if there are multiple ways to generate length 3, if there are multiple ways you can perform operation, and you can end up having different length 3 strings as final result, then you have to print the smallest lexigraphically smallest string. For example, if the final string is 111, 101 and 011, in all of these strings 011, all of these strings, all of them are length 3 strings, but 011 is the lexigraphically smallest one all out of these three. So we will be printing 011. So what we have to do, we have to make the string as smaller as possible, and if there are multiple smallest string that we can obtain, then we have to print the one which is lexigraphically the smallest one. So this is the task. Now if you see, these are the test cases, example test cases. There are 5 test cases, the number of characters, and this is the input string. So this is the answer for the second input. This is the answer, and for second input 001 you can obtain by you see one, there exists 10 this. So what you can do, you can remove this one, so the string would become 001. Now after becoming 001, you can't perform any further deletion because there is no substring which is of type 10. So there's no 10, so you can't perform any subtraction. So the question, for example, here what you can do, you see this forms 10. So what you can do, you can remove this 0, then the next substring will come, this gets removed, so this and this are next to each other, again forming 10. So you can remove this. Now this and this are next to each other, so you can remove this. Similarly, you can remove all of them, but it is possible when you remove from here to here, now the last 0 remains. What it would do, it forms 10, so what it would do, it would remove this one. Now these two are next to each other, so it would remove this one, and similarly this one. So at the end of it, you would be having only 0. That is the smallest string you can obtain. You can also obtain the smallest string as 1 by removing all of the zeros and the last two ones. But among if you take a look at the string 0 and 1, lexigraphically smallest is 0. That is why we are printing 0. The question is how we would be able to solve this problem. So the solving of the problem is literally very easy. So first observation is that after after all the ones which are at the end of the last 0, so there exists, if you scan the string from left to right and you find the last 0, after that last 0, all of the character must be 1. That's the reason why that character is the last 0. After last 0, all of the characters are 1, and all of the ones after last zero, you can't remove them, and all of the zeros before the first one, you can't remove them either. So let's call beg the substring of all of the one before all of the zeros before the first one, and n will be the substring of all of the ones after last zero. So this would be a substring of all of the zeros before first one, and this would be a substring of all of the one after last zero. If I show you one example explaining this, you can understand it from this example test case. Now see, this is the first one, so all of the zeros that appear just before it, they can never be deleted. For them to be deleted, there must be one which is before them, but this is the first one, that means there is no one before them. That is why these zero can never be deleted. So beg would be the substring 000, all of the zero before first one. Now similarly, all of the ones which are there after the last zero, they can never be deleted as well. For example, all of these ones appear after the last zero. These can be removed if and only if somehow these form 10 substring 10, right? So that means there must be at least 10 after them, so that a substring 10 is formed, so that I can remove one, then again 10 would be formed and I can remove again one, and so on. But since there is no zero after them, because these are the ones after the last zero, so there is no zero after them, that is why these ones can never be deleted. That is why the AND would be formed of the ones which are after the last zero. So we have to keep track of the first one, the position of first one, and position of last zero. So we will be forming a substring beg would it would be containing all of the zeros before first one, and would contain all of the ones before after last zero. Now the crazy thing is, the result is either beginning plus n or beginning plus 0 plus n. The first one is easy to understand, you can understand it with this example. The second one, we have to see another important observation. Let's go for the first one. Now see, the result is beginning plus n in the condition where the size of the sum of the sizes of the substring beginning plus n is equals to n. That means beginning plus n contain all of the character of the input string, and this is exactly the first example test case. You see, beginning will contain all of the zeros and n will contain all of the ones, which means the size of beginning plus size of n is equals to the input string length. That means you can't perform any operation. Why it is happening is that all of the zeros, this would happen if and only if all of the zero appear on the left side and all of the ones appear on the right hand side. In that case, there is not even a single operation that you can perform, and in that case, of course, the result is going to be that string itself. So if let me show you the code. If the beginning dot size plus end of size is equals to n, and n is the input string size, then the result is going to be beginning plus n. These are strings, so I can concatenate them with plus sign. Otherwise the result is going to be beginning plus 0 plus n. And why is that so? Let's go for the second observation. I hope the first observation is clear, that all of the zeros before first one and all of the ones after last zero can never be related. Just make sure this observation is very clear to you and you are able to see why this is happening. If you are able to understand this, then you must be understanding why the result is beginning plus n. After that, let's go for the second observation. Second observation says that all of the characters that lie between the first zero and all of the characters that lie between the first one and the last zero can be removed always. Now, why is that so? Let me show you with an example, and I need to take an example to make things clear. When you take an example, things get we are able to understand things easily. Now see here, the appearance of first one is here, so this forms a beg. The appearance of last zero is here, so this forms and. So beginning is equals to double zero, and is equals to double one. Double zero because these two characters, these two zeros are appearing before the first one, and double one is the and because these two ones are appearing after the last zero. Now this is the substring that we need to take care about, because we know these two will always appear in the answer no matter what, because we cannot remove these two substring, the beginning and the end, we cannot remove them. So now we are left with this substring only. Now observation 2 says that you are able to remove all of the characters between the first one and the last zero. That means you are able to remove all of these characters. Now why is that so? Now see, to understand this better, for every single zero, for every sorry, if there exists a zero in between the first one and the last zero, in between the first one and the last zero, that means I am talking about this substring. If there exists a zero, then there must be a one just left to it. If there exists even a single zero in this substring, then there must be a one just before it. So to understand this better, just start from this index. That means from for this substring, start from the leftmost index, and then keep what we call it, keep traversing the string, right? Whenever you find the first zero, just stop. So you start from here, you find the first zero and you stop, and when you stop here, you are certain that the character just before it is actually 1, right? And how we can be so sure? Because the first character itself is the 0. What am I saying? The first character itself is 1, because we are talking about the substring which starts from the first one. That means the first character will be 1, and the last 0, that means the last character would be 0. So if you scan the substring, the remaining substring, this substring from left to right, the first 0 that you would find, the character just before it will be 1 always, and this one right here, make sure that this happens always. So the first 0 that you would find from from scanning this substring from left to right will always have a the first 0 that we would find from left to right scanning this substring will always have 1 just before it. That would make a substring 10. If you can make a substring 10, what you can do, you can remove 0. For now, just we can remove 0 or 1. Let's just remove 0. So I am able to remove this 0, then the first 0 from left to right scanning would be this, so I will be able to remove this as well. Similarly for this and this, we won't remove the last 0. So let me show you an example which doesn't follow this but still is able to delete characters. What I have done here, I have removed this character because just before it is 1, so I have removed this, so the new string would look like 0010100, right? Now I can do again same thing. I can remove one more 0 from here, so this would form the next substring. Similarly, I can remove this as well. I can remove this. What have I deleted? I have deleted this. Similarly, I can remove this. Now I can so this forms the new substring. Similarly, I can remove this, and next I can remove this. Now these are the remaining characters which are 1. So using this 0, I can remove all of this, because in the first step I can remove this because this forms 10, so I can remove this. So this gets deleted, so this forms 10, I can delete this, and so on. So I will be deleting it till I have 10, the first character and the last character. Basically we have deleted all of the characters inside the boundary of this 10, the first one and the last 0. Between that boundary we have deleted all the character, and we will be able to do this all the time because as explained before, if you scan the string from left to right, the first 0 you would find will always have 1 to its left. That means you can remove that 0, and this so you would be able to remove this 0. After removing this, then the first 0 that you would find is this, so you can delete this as well. Similarly for this, every single 0 you will be able to delete, but do not delete the last 0. After you have deleted all of the 0, now you can eliminate all of the ones using this 0. So now we will be able to remove all of the substring that lies in between the first one and the last 0. Now we are left with this, the beginning, in between we have this, and the end. Now this forms a substring 10. That means you are able to delete this as well. So which character should you delete? Should you delete 1 or should you delete 0? Now if you delete 0, the result would form 0 0 1 1 1, 0 0 in between 1 because of this, and at the end we have 1 1. If you remove this one, you would have 0 0 in between 0 and 1 1. Now you see 0 0 0 1 1 is lexicographically smaller than 0 0 1 1 1. If the ith character in both of the string is either 0 or 1, so it is better to go with 0 because that would form lexicographically smallest string. So basically this observation says that all of the character between the first one and the last 0 can be deleted, so we have deleted. Now we are left with 1 0. In 1 0 we will be deleting 1, so that we are left with 0 only. So that means beginning plus 0 plus end, this would be the result, and this would be lexicographically smallest one. So if I show you the code, you will be able to understand it easily. Now sorry, this is the character array. The input size is, I guess, 2 into 10 power 5. For each test case we are reading n, and we are initializing a string beginning and end with empty string, right? Now this is last and first. Last would take care of the index of the last 0, and this would take care of the index of the first one. So this is for loops, runs from 1 to n. For each character we are reading in the character array. Now if the ith character is 0, that means last you will be initializing last with I. So at the end of this for loop, last would contain the index of the last 0. Now similarly, if ith character is not 0, that means it must be 1. If this is 1 and first is equals to -1, then first will be initialized with I. That means first, why I have initialized first with -1 or and last with n plus 1, because all of the both of these are actually invalid indices. Since I am working with one base index system, so 1 to n is the only valid index. Now -1 is invalid index, n plus 1 is invalid index. Now why specifically chosen -1 and n plus 1? Let me show you. Now the beginning substring will contain all of the characters before the appearance of first one, right? Now if you initialize first with -1, and there is, you can also initialize with 0, I guess. Yeah, you can also initialize with 0, and this would work perfectly fine. Now if there exists no one in the whole string, if there exists no one, that means first is going to be -1 after running this whole for loop. If first is equals to -1, if there exists no one, that means there is no substring before the first one. That means in the beginning string we should not be able to add any character, right? If there exists no one, that means there is no substring before the first one, because there is no one. So the beginning string must be empty, or you should not be able to add any character to it. So if you initialize first to be -1, that means after running whole loop, the first would be -1. So if you run the loop from 1 to less than first is already -1, this for loop will not run. So I have initialized first with -1 to make sure that if no one is appearing there in the input, so we are not able to add any character in the beginning string. Similarly for last, if no 0 is appearing in the input string, that means last is going to be n plus 1 after running this whole for loop. That means all of the character after last will not be able to add into it, because there is no 0. That means there is no substring after the last 0, because there is no 0. So you won't be able to add any character in the end substring. That's why I've initialized last with n plus 1 and first with minus 1. Otherwise you should be able to add the character before first. So initialize I with 1 and go till I is less than first and add each character one by one into beginning. So pb is actually pushback. Pushback is a function which is used to insert character by character in the string, or this is basically a function to insert an element at the end of the list, be it vector or string. So I've initialized it with with empty substring. So I'm adding character by character in the beginning and the end substring. So after running these two for loops, and beginning and end contain the beginning and the end of the string, which will always appear in the answer. So if the size of the beginning plus end is equals to n, that means this is the result itself. Otherwise, if last is equals to n plus 1, that means there is no last represents 0, I guess. Yeah, there is no 0, right? Or if first is equals to minus 1, that means there is no 1. So if last is equals to n plus 1, that means there is no 0. That means the whole string is consisting only once. That means you can't perform any operation. That means you have to print the whole string, and that is what I'm doing here. I'm printing the whole string. If the first is equals to minus 1, that means there is no 1. The whole string is actually 0. That means you have to print the whole string because you can't perform any operation. Otherwise, if these two conditions fail, that means there exists 1 and 0 as well, and that means the result is going to be beginning plus 0 plus end. That means in the beginning you can append 0, and then beginning plus end would be your result. So this is how you solve this problem. Of course, if you have any doubt or query, you can ask me in the comment section. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.